Welcome, everyone. I'm so excited to be starting today's Goliath 101 webinar. My name is Mike Stish. I'm a firmware engineer at Goliath, and I'm joined by Marco Puric, who is a field application engineer at Goliath. How are you, Marco?
Doing good, doing good. You?
Doing well. I'm pretty excited to show off Goliath today. I have to look over here because you're over here and my camera's over here, so it'll look a little weird. I see we are also joined by a bunch of awesome Goliath people. So Jonathan Barry, our founder, is in on the call as well today. Ariana Faustini, who is our head of global marketing, is here, and I think I saw, yep, Chris Gamble, who is the DevRel lead, is here as well. So tons of people. I don't actually see who's in the room watching on this interface, but all along the point is to like interact with your questions. So if you have something going on, we will see it come up in the chat, and then I think we'll put it up on our screen and go from that point. But anything to add before we jump in, Marco?
Uh, I don't. I think you got it all covered. So let's get into it.
All right, cool. So this is our Goliath 101 today. Really, we're looking at the user experience that you're going to have starting up with Goliath as an IoT development platform. And I think the first thing to answer is, what is Goliath? The best thing to think about Goliath as is the cloud product itself. So the ability for you to connect microcontroller level devices securely to the cloud, and then have that data and control for those devices be available on the other side. On this graphic, you can see over on the left, we have an IoT fleet. We do have a firmware SDK that covers many, many different platforms through Zephyr, RTOS, and through ESP-IDF, where are two of the supported platforms. You get a huge variety of vendor devices that way, and we also support Modus Toolbox. We have a porting guide, so if you have something that's not covered by one of those, their chances are pretty good that we can get up and running in Goliath with a little port work. So reach out to us if you have questions about that. This also indicates our connection methods, which are cellular, Wi-Fi, Thread, and Ethernet. Basically, if it has like an IP address, it can probably work with Goliath. On the other side of things, there are optional cloud side components that you can choose to use. And we find that most customers have one or several of these. So like the ability to use a database platform. So if you normally like to have your data going into Influx or Mongo, we have connections and for those. If you're using cloud servers for your backend, so if you have stuff that's up on AWS or over on Azure or Google Cloud Platform, we also can seamlessly connect your data there. And of course, lots of people are asking about, I have end user apps that need to somehow interact with them. We have the ability to connect to those, as well as business logic, all through our data routing and device management platform. I would like to call out that you don't need to use those. Like we have data storage and handling built into Goliath, but our goal is to go where you want your data to go rather than for you to have to come to us with that. And so we try to make it as useful as possible. And of course, if there's anything that you're not figuring out how to do, like we want to hear about it. There's a good chance we can help you figure it out. And if not, it might be something that we add to our product roadmap. So please feel free to reach out. I guess I will get to a slide that talks about reaching out in a moment. The things that we're going to talk about today are mostly, pardon me, going to revolve around the Goliath Web Console as a way to kind of demonstrate our product. And that's the thing that as you prototype, you're going to get most comfortable with first. So I think it makes sense to go over that today. We'll do just a walkthrough of the sign up and the little wizard that starts to create device credentials. We'll talk about working with those device credentials and then do actual examples of seeing data coming to and from the device. We'll look at how the data routing is set up and works. We'll talk a little bit about device management, so how you control your device and get information to it and change its behavior out in the field. And we'll finish up with my favorite, which is OTA firmware update. Some interesting things, like if you don't take anything else out of this talk, take these 4 links because I think they are a good place to go. The first is, and actually I'm going to show them as I go. So the first is docs.goliath.io, which is our here, it's this one right here, which is our documentation. So a great place to look is this getting started guide. This is going to walk through pretty much the first half of this webinar and getting you signed up for the console. There's also the ability to run some precompiled binaries. I'll be showing this one off on the Thingy 91 today. And then also the quick starts for getting you up and running with different development environments and compiling code for your devices. So a great resource there. The forum is a wonderful place to ask questions. Chances are, if you have the question, someone else is going to have that question as well. So we'd really like to see a thread in the forum that people can find help there. Let's see, this is what the forum looks like. I don't know why I'm showing you this. I think you know what forums are, but go and ask questions and see what's going on over there on the forum. A wonderful place for examples of how we like to do things at Goliath, or like approaches to use cases, is projects.goliath.io. This is our collection of reference designs. These are kind of like businesses in a box, or like end-to-end from the device to the cloud sort of thing. They are open source, and so you can go ahead and get the code and see what's going on in the code, even if it's not your exact use case. And we have what we call follow-along hardware on these. So there are, let's see right here, the components that you actually buy off the shelf. You can just like get a DigiKey cart and order these and start running the code right away. If one of these is close to your use case, it might be a good place to start with your prototyping, because it's like already up, talking to the cloud and running, as well as like doing visualization. So this is a blank image. All right. Oh, this actually went to the dashboard. So this is a dashboard view of information coming from a device. So it's kind of like a rapid, dash to the finish line on your proof of concept to start from one of these designs. And I think the last one is blog.goliath.io. Every time we learn something interesting technologically, we publish it there. We also, of course, talk about all the new features that are going on with Goliath, and it's a great way to keep in touch on what is happening. All right, so let's jump into the demo. So the first thing we're going to do is just console sign up and overview. Pretty much everything for Goliath is going to start at console.goliath.io. And one thing that I wanted to mention is as we run through the console examples, anything that you see happening on this site is happening through our REST API. And so you should be able to do this with your app if you need to, and anything that we're doing here. So let's just start with a webinar, I don't know, 2024-02 maybe. Oh, I'm going to need to actually sign up, not just sign in. And all right. And I agree to my terms of service. We're going to ask a few questions on this just to kind of get to know you and find out what your interests are in Goliath, so we can help with our roadmap on things that we need to build out. So I'm a firmware engineer. My team is 5 to 20. I'm currently in the prototyping phase, and I'm going to deploy dozens of devices. So just a few of those quick questions, and then we plop right down into the console. So this is our web console that is a window into your IoT fleet. So right now, I don't have any devices in my fleet. And I see I just, out of habit, clicked away on the wizard. The wizard would have led me to this create a project device. So I actually need to choose a project name. So I'm going to choose Mike's project. Let's see if they'll let me use that. I don't know if you can use punctuation. Yeah, you can use punctuation. All right, so I have Mike's project on my Mike Webinar 2024-02 account. Now that I've created the project, I get my wizard back, and it prompts us to add a device. We don't have any virtual representations of a device, which is something you need to have in order to connect to Fleet. So I'm going to go ahead and create that. It will give you an automatic name, or you can choose a name here. My NRF 9160. Tags are a way of organizing your devices. Right now, I'm going to start without tags, but I will demonstrate that a little bit later, how we tend to use those tags. With hardware IDs, some people like to use like a MAC address or an IMEI or some other like device-specific number. Since I'm just imagining this, I don't need to do that. And then you can choose to set your credentials manually. In this case, I'm just going to have them auto-generate credentials. And so at this point, we get a summary window of the device that I've just created that talks about the PSK ID and the PSK, which is like a password for this device. And I can copy them and use them right there. I'm going to go ahead and click the done for just for right now. And we can see that we have a summary of our device, and it tells us our device has never connected. So think about this as the digital representation of something that's actually in the physical world. At this point, since I don't have a piece of hardware, I'm actually going to use our simulator, which is down here, and that's the next prompt on the journey. It has some data already in there that is kind of like dummy data that we can send. But because Golioth is secure by default, we need to give it credentials in order, even for the in-console simulator to work, it needs to authenticate. So I'm going to go to this credentials tab right here. I'm just going to close this for a second. And you can see the PSK ID and PSK, think about it like username and password that were set up when we first signed in are there and available for us to copy. So if I copy those out into the window, all right, so now I have my authentication for this device simulator in place, and I can send this data. And so this is the structure that we just sent. If we go into the LightDB stream, this is our streaming data window, we can see that just came through. So like we've accomplished something, we signed up, we just sent our first device data packet, and we got it on the cloud, which is pretty cool. However, I am a firmware-y type of guy, so I really like to work with actual devices. So I do have a device right here that already has a piece of Golioth sample on it to send some temperature values. I'm going to switch over. I'm just going to minimize this, I think. I'm going to switch over to this project that I previously set up, which currently doesn't have any devices in it. So I'm going to, again, go ahead and just create a device. I'm going to leave the name. Maybe I'll change the name. Let's call it ESP32. I'm going to leave everything else the same. And for this device, let's see. Just working on some other stuff. I'm going to plug the device in. And the way that this one works is it just takes a couple of command line or serial terminal settings in order to set those values, because once again, we're secure by default. All right, and so I've put those in. And I'm just going to reboot the device, give it a chance to connect to my Wi-Fi network, and then we should see it connecting to Golioth as well. All right, so connected to Wi-Fi and Golioth. And if we go to the device summary for this that we just created, we can see now that it was online a few seconds ago. It last reported a few seconds ago. And again, our streaming data, we already have data coming in. So it's pretty cool to see that. You can see those
Mike,
are the yes, go ahead.
can you maybe make your text a bit bigger if
Yeah, that's a
folks
good
don't
idea.
see it?
Thanks. All right. A little better?
Awesome.
All right. Cool. So we have one device on our fleet now, but a fleet of one devices is kind of sad. And so I actually prepared another board. So the first one is an ESP32 on Wi-Fi. This one is a cellular board, NRF 9160. They're running the same firmware because Zephyr is cross-platform, cross-vendor. But with this one, I changed the authentication method. So in the demo so far, I've been showing pre-shared key authentication, which is secure, but it's not as secure as certificate authentication. And so I've actually created an X509 certificate, which uses the ECDSA encryption, and I've provisioned it onto this device. So you can think about this coming out of the factory with a certificate already stored on it. Golioth as a platform doesn't actually know about this device, but I have, in the project settings, I have uploaded a public root certificate, and the private key for this root certificate was used to sign the device certificate that's on here. So even though Golioth doesn't know anything about this device, when this device tries to log in, it will test the certificate out against this root certificate that's on here, and it will realize that, oh yeah, I know who that device is, and Golioth will automatically provision the device. So I just plugged it in, it should be coming up right now. And we'll see, maybe I want to change where I'm looking here.
This step always feels like magic to me.
I feel the same way, assuming that it comes up. I can't. Oh, there we go. All right. So it has already come up. I didn't catch the serial output, but that's fine. The point is you should just be able to pull these in and they should come up. So we didn't have this NRF91 cert device before. Now we do. I actually never look in the credentials. So we don't have a pre-shared key for this one because we used certificates, which is kind of the nice way to go. And you should see that we are sending data from this one. So we can already see our sensor data coming in just like the other. This kind of covers this part of like the signing up, getting credentials. If you have questions on that, please put them in the chat here, but I'm going to go on to the next slide. So we looked at credentials and we looked at those devices and accessing the PSK credentials. So if you ever do need to go back and get the credentials or create new credentials or delete credentials, going into the devices view, choosing your device, and clicking the credentials tab is where you would do that. And you can get at these once again. Moving right along, we have device data. So while we're streaming this device data, there are a couple of different things that we can look at. The first one that I like to look at is the actual time series data. So think about this like sensor data. You have a temperature sensor that reads what temperature it is right now. You're probably want to know what temperature it is 10 minutes from now, but also have access to that previous temperature. So what you want is like a ledger of one reading after another with a timestamp on them. And that's what we've been looking at on this LightDB stream tab for these devices. So you can see 11:17:08, 11:17:03. We are on like a 5-second cadence for all these, and we're just getting the different temperatures. And this would allow you to graph temperatures. So again, this is what we call stream. The thing is, I'm just looking at one device right now because I'm on the devices tab. Golioth does have the ability for you to go over to this monitor on the sidebar and click on LightDB stream. And then you get that stream data you can see for both devices here. And I can click expand and see what that data is. At times I find that it's not very helpful to just expand this because sometimes I have 40 different data values in these JSON objects. And so in this view, we actually have a query builder that allows you to choose what fields you're looking at. In this case, the star is just giving us all the fields, but I could change this to sensor.temp. I could give it a name like temperature. And then I can see I get a column with the temperature here. And this is full featured. So you can do things like do a running average of samples and filter out samples in different ways. Basically, you add filters. If you're used to manipulating like JSON path, I think is the manipulation that we normally use, you can probably figure out how to do it here. I do a lot of my building and then for other platforms here and testing it out. And then I take this like into our visualization platform and use it that way.
And Mike,
So yeah, go ahead.
from where is the timestamp coming from? Like, can I set it in a device or is it set in the cloud, or can you explain a bit more on that?
Yeah, that's a good question. So if we looked at the simulator right here, when we sent this data, we didn't include any kind of timestamp in it. And with this service, this stream data service, Golioth is going to automatically assign a timestamp that is the time at which that packet arrived at the Golioth server. But for instance, I've made GPS examples before where you actually want to use the timestamp from the GPS reading because it's super accurate, and two, you might cache those. Like if you don't have an LTE signal for a while because you're in a tunnel, I suppose you wouldn't have GPS either. But if for some reason you don't have connectivity, you can cache values and then you can add them using a key like T, TS, or timestamp. And this is listed in the Golioth docs as well. And then it's like, it's the whatever the ISO specification is for this. So it's like, 2024 02 15 something something. But again, this docs page is a great place to go and look for it. It would be, I'm not gonna drill down and find it right now. I can maybe search for it. Let's see.
This is the real
Custom
test.
timestamps. Yeah. All right, so custom timestamps. So here you can see the format from that, and we talk about adding for that. And you can mix and match. So you can have some things coming into Golioth with timestamps and some things not, and they'll get sorted out on the server side.
Thank you.
All right. So that was one of the types of data. That was the stream data time series. I often think about that for sensors. Another type is the state data. And I think I'm actually going to switch over to a different example for that. So give me just a sec here to switch to the Thingy 91. All right. I'm going to unplug these devices because they're not needed for right now. So I have the case taken off of this. There's this wonderful device called the Thingy 91 that is like a consumer product. It's got like a plastic case and a rubber cover and a button and an LED and a light sensor and all kinds of good stuff on there. It's cellular modem. And I have this connected to Golioth right now. We use this for a lot of our demos. And here you can see Mike's Thingy 91. Online 2 hours ago means that that was the last time we had a DTLS packet on the server for it, but it last reported a few seconds ago. So I expect if I refresh this, well, the connection says hasn't updated yet, but I'm pretty sure we're connected. So I think that's just a delay in reporting. So we were looking at streaming data before. You can see streaming data coming in here from this. You can see there's a lot more here, so filtering this might be a good idea. But the other type of data that we have is stateful data. And so one of the things that maybe doesn't matter so much is like how often a sensor reading was made is kind of stored in the data itself, but you might want to know like how many sensor readings, just like the device reporting its like cumulative state. And here I have this. So when this comes up and runs again, I think it's going to just start the counters from where they were previously. So the device is able to store its state in the cloud. That way you can access it, but the device can also pull it down later on. And this will beep every time I push it. And so you can see there, it's gone up to 51, 52, should go up to 53. There's a little bit of latency because of the LTE network, but it's pretty responsive to that. And so a great place for using what we call digital twin. And in this case, there's a digital version, there's a version in reality, the physical version, those are the twins, and they represent each other. And in this pattern, only the device, we choose to only let the device write to state. So this is the last thing that the device indicated to the cloud. But this service is bidirectional. So for instance, if you wanted to tell the device, hey, don't count down from 8738. Instead, why don't you count down from 2000? Because we need to do that. So I can actually edit that here and then submit that to the device. And we should see that turned to 2000. And then this desired state was set back to -1, indicating that the device got it. So it was the device that did the move of that desired value down to the actual state value. We could do the same thing with the up counter. You probably want this to be set to 42. And you can send that, and you can see the latency for this is really low. So already the device has gotten that instruction and has updated that. Some other things that I find are useful for LightDB state are like if you have specific types of calibration values that you want to put here, you might choose to put them in LightDB state because they'll be persistent there. Like anytime the device logs in to check on this, that value is going to be waiting for that device to download. I want to take a sec to answer some of these questions. Let's see. First one, I'm just going to read these live. In the example of provisioning the device by the certificate, which device/ID name is used? I suppose that it should be unique, but if it just comes from factory, which would be the device ID? Maybe the IMEI. So you actually get to choose what the device Not necessarily what the device name is going to be, but what the device indicator is going to be. And so I think we just updated our docs on how this works. Let me see if I can find that as well. Certificate, maybe this one, not this one. It might be this one. I can actually, rather than looking for it in the docs right now, I can show you. Where was I? Developer training. So I think that there is a way to find out. So I'm kind of coming up. Oh, here it is. All right. This is it. This primary hardware ID. This was set based on the certificate number that I passed. And so when I made the certificate, I used the name NRF 9160 or NRF 91-cert, and you can change the name of this device, but the certificate is going to have this ID that's used for the primary hardware ID. So my suggestion, I guess, in your case is you choose what you want to name, the naming scheme that you want to use for the device, and then that is going to be assigned to this particular certificate by the server, so that even if you change your device name later, it will recognize the certificate as being unique to this device. I feel like that was a rambling answer, Marco. Was that okay?
I think that was okay.
Okay. Let's see this one. Considering the provisioning phase for the final product, when we have dozens of product, how does it work to generate a load of certificates on a target device? Generate and load the certificate. So I think that really is dependent on your manufacturing process, and you should discuss with us on that. I think no matter what manufacturing process you have, you're going to need to have something unique on the device. And so you need to plan for that step. In some cases, like this, this example I did with the Nordic device, it has a secure key store on the chip. And I believe Nordic has a provisioning service that works with that secure key store. So you could come up with a plan that places the certificate there based on like a cloud provisioning. This is something that we've been talking to them about doing integration on. So it's on our radar. We don't have that out of the box yet, but everyone's facing that same problem. And so making that easier to solve is one of our goals. Let's see. Digital twins are the best invention of IoT. Great. I do like the digital twin stuff. I feel like I only know a portion of the, maybe it's not solidified into an agreed upon thing, but every time I find a new digital twin approach for something, it's really cool. Some things that are really difficult about it are like the instability of network connections, right? So you might have a device that's down for a long time. And so digital twin, it really gives you that, like, what did the device last report it stayed as? And can I debug based on what I know about that time period and what's going on? So I like that idea of like an immutable source of truth on what the device has said is going on versus what the cloud actually has told it to do and is thinking of has been really useful. All right, I don't have a clock up. I can just look at my watch. Oh, I burned so much time. Let's see. We were looking at state data, so we just looked at that. I think we're kind of done with those. We looked at the fleet view, looking at your entire fleet. I think. Did we look at that? Yeah, I think we did. Other things that we want to talk about are data routing. So I showed those dotted boxes of optional add-ons if you wanted to have something like an external database or a cloud service or your app or some business logic. And one of the things that I really like about Golioth is it makes it really easy to add those integrations. So under our project settings, there is something called output streams, and there are a number of built-in integrations already set up for you in order to use these. So any of these services are going to work very easily. For instance, if you wanted to set up MongoDB, here are the options for that. Now, what do I do here? Like, what do I put in these boxes? We have actually walked through each part of that under our data routing on our docs page, docs.golioth.io. Under output streams, we go through with instructions and pictures of where to get the stuff to actually put in. We want this to be as easy as possible. I am not a cloud first person, and I am able to follow these and get it working quite easily. So that makes me happy. So take a look at that. We also have this set of open API docs here. So if you want to use the REST API, a great tool under reference and REST API and open API docs, you can see all of the REST APIs that we have here, and they talk about like, how to you get the parameters for each call and what you're going to be looking for a successful response and an unexpected response. I don't know why I'm telling you this. If you're used to Swagger and Open API docs, you've definitely already seen this. The place that we use it extensively is in visualizations. So this is the visualization platform for the Thingy 91 demo that was showing off. This has a light sensor in it. It has a gas sensor and temperature sensor in it. So we're getting live updates on all of these things. It's got an accelerometer. So if I turn it upside down, some of these values should become positive. You can see they already reacted. And this, let's see, how do I get out of that? There we go. We actually have it set up so you can select which device. I don't think anybody else's devices are on right now. Maybe Marco's is on, or it's been on earlier today, so we can actually see Marco's data on there. So it's a really great thing. And this is using a combination of REST API and WebSockets. So REST API is like polling for data, and then WebSockets is going to be as soon as the data hits the Golioth server, it gets sent on to your integration. And if you are like a dev shop, or if you have a boss that wants to see like, hey, what's this IoT thing all about? Like, what's going on? Like, pulling together a visualization like this is a really easy way to get your project a yes rather than a no. So we definitely appreciate that. Going right along, device management. All right, so we have all these devices in the field. We're getting data from them. That's great. But we need to change a setting, or we need to, one of them's not behaving right, and we need to troubleshoot it, or a bunch of other things that always happen with IoT fleets. We have built these services maybe before you think about them, so that they're there for you to use right away. The first is the settings service. This is going to allow you to specify a setting that all devices should have access to, but then you can get granular control by drilling down to groups of devices or individual devices. Demonstrate that in just a sec. RPC is remote procedure call. So if you want to run a function on your device, and you can supply it with data that you didn't have when you compiled the firmware, and you can get an answer back from the device, which is really awesome. I will also demonstrate that. And finally, remote logging. I will show this as well here, as well as in the OTA example. So I think first is device settings. In this case, we're taking readings on a regular cadence for this Thingy 91 device. But what if I wanted that regular cadence to be different? So first of all, there is a left sidebar setting for device settings on the wrong project. Sorry, I switched over for an example. All right, so we're on the Thingy 91 project, and under device settings, you can see we've got a whole bunch of settings. These are like the defaults that each of the device use. So a loop delay of 5 seconds, that means take a reading every 5 seconds. And then the color of the light, it's set to come up as full red project wide here, but you can mix in blue or green. This is our percentages, PCT. And then the fading speed. So I don't know if you can see, but there's like a heartbeat on this light, and this decides in milliseconds how fast it fades. If I change one of these here, if I say I want my readings to be every 10 seconds, it's going to give me a warning that said, this value was 5, you're changing it to 10. This will impact 7 devices on your fleet. If you have 1 million devices out in the field and you thought you were changing a device for one, you definitely want a window like this. So I'm not going to change this fleet-wide. The other place that I could change it is using blueprints. We're not using blueprints in this project, but I will show that in a little while. But I want to go down and just change it for my device. So again, I went to the devices tab on the left sidebar. I chose the device that's on my desk right now, and there is a settings tab on here, and you can see all of the current settings, but you can also see the level at which they're being set, either on the blueprint level, the project level, or the device level. And so I'm going to change this one to 10. So we only get a reading every 10 seconds. And we can see that this device has, that this is now using the device value, that the project value is set to 5, but my device is overriding that to 10. And if I refresh this, we can see it's in sync a few seconds ago. So it knows that the device got the setting. I think if I changed it to something crazy, I think it will not let me do this. Let's see here. It will tell me that the device reported the setting status with an error, and it says the value is outside the allowed range. So I tried, you don't want your device to sleep for 55,555 seconds. That was probably a misplaced finger on the keyboard there. So we've set that up in the app. That's not enforced by the Golioth cloud. What is the difference between device settings and digital twins? Are they intended to be used for different purposes? Yeah, this is a good question. All right, so one of the things is you may have a subset of devices that operate on different concepts. And so if you, let's say you had, I don't know, 4 different use cases for your device fleet, and each of them had, 10 different settings that were kind of unique to them, you'd have 40 settings in here. And then you'd have to deal with it in firmware, like what's going on. The other thing is you have to place in here an exact key for a setting, and the firmware needs to know that exact key. So it's like you need to know right now, like what's going on. Whereas with the LightDB state that offers digital twin, you might be able to have a JSON object in here that has keys that you hadn't planned on, and have your firmware process those keys in a certain way that makes sense to you. So what's a good example of that? Yeah, I'm not sure, but basically I can put a JSON object into this LightDB state, and the device can be responsible for dealing with that. So if there's something unexpected, I think you get a little bit more complexity here. On the other hand, if you are using this digital twin, you have to make the state for each device. So you would need to use like your backend business logic to update that for a large myriad of devices. So you have to go in and do it manually. However, the settings service allows you to do that for groups of devices, and it will kind of happen automatically. So it kind of depends on where is the difficulty going to lie. Do I want to make sure that like it's very tightly constrained, it applies to all devices, and there are some guardrails so I don't like accidentally make things happen? Or do I need a little bit of flexibility to send data that maybe I wasn't expecting before?
Yeah, and if I'm not mistaken, the LightDB state is bidirectional, and the settings are from the cloud to the device.
Yeah, that's right. We get a status message back from the device, but it's really just like a number of return code for the setting being processed. So you don't get a lot back. However, let's move on to the next part of device management here, which is the remote procedure call. Now, I really love this because if you have a function that you didn't know what the inputs were going to be, you could assign it here. So one of the fun ones here, since we have a piezo buzzer on here, Chris, when he worked on this one, decided to use that buzzer. So if I call this remote procedure call with the text Funky Town in there, no response. Let's try it again. Am I connected? What device am I on?
Maybe try it with my device.
Oh, is your device currently on? Okay. I may have lost cell connection for a moment. I'm not sure. There we go. All right, so I must be having an LTE issue right now. So that is one of the drawbacks of the remote procedure call, is that if the device is not connected, it will not respond to the remote procedure call. You can decide the timeout, but the remote procedure call is like, it's a synchronous thing. It happens right now. However, LightDB state, the device will check this when it powers up. And so you could make changes here even when the device is not connected to the network. So if you have something that goes into low power sleep mode, they would be able to get that here. Same with settings. Settings will get checked If you set it when the device is off, the device will check it when it first attaches. So the other thing that I really like here is, so that played a song, great, but I can actually get data back from these devices. So if I just ask Marco's device to send me its network info,
I think I'm on
Marco,
the, yeah, I'm not on the
yeah,
updated firmware because I'm on
yeah.
the
So we
NB-IoT
will.
server.
So yeah, Marco's running a different version of the firmware. So you can see I'm running 1.0.100, and Marco is running 1.0.0. So that feature is not currently available in his. I'm going to try mine again and see if we have connectivity. Oh, so sad. I'll place it somewhere towards a window, maybe. There we go. All right. So I was able to go and query this and see what its network situation was. And I get all of the information on here that might be really useful. The other thing that I've used this for before is key rotation. So I've actually uploaded new credentials to the device, and I had a function that would verify those credentials, try to connect with them, make sure the connection was good, and then switch to them. So it's almost like an OTA update, but for credentials instead of OTA. The thing is, you can like compile new firmware and send it up to the device. But if you think about like the risk involved, like, okay, I compiled new firmware. Did I introduce a bug when I compiled new firmware? Like there's a lot of testing overhead for that. Or just the fact that if you have a million devices in the field and you're sending, 400 kilobyte binary, like you could, there's a cost that you might incur on like cellular data for that. If you can instead build the same functionality you need into like a remote procedure call, it is kind of like a nice alternative to doing like a full firmware update. All right, so I belabored, logs. I got to show logs. Sorry, folks. How am I doing at time? I'm out of time. We're going to go over a little bit. I apologize, but it's just too cool, this stuff, for us to not show it off. All right. The last one is logs. So I can actually go and look at device logs that are coming in from Golioth. You can see I'm getting some logs about the actual like connection that are coming across. I have full debug logs enabled here. So I could actually pare that down a little bit and just look at like info logs that are coming in. And in this case, I can see things like my loop delay was set to 5 seconds. So if I go and change my settings again to 10 seconds, I probably should have put my logs on auto refresh, but that's okay. And I update this. We should get a message from the device. I think, again, I'm having connection issues. Whose device am I looking at? All right. Well, we'll try a firmware update. We should be able to get more information on this. These logs are really helpful for troubleshooting. I've also used the remote procedure call to turn the logging on and off because, again, if you're sending all these logs over cellular and you don't actually need them, you're just spending cellular data. So you could turn them off for a device that is working fine. Some people make it so that it will send logs for the first like X number of minutes after a reboot. So that if you have a device that's giving you a problem, you can tell it to reboot, and then that'll turn the logs on for a little while, or you can send a remote procedure call. But it's really useful to be able to see your last 4 hours, last 24 hours, however many logs you're interested in coming across from that device in order to troubleshoot it. Moving right along. All right, our last slide, OTA firmware updates. So if you have devices in the field, you need to be able to update the firmware without someone driving out there and connecting a USB cable or some other programmer to it. And Golioth has that built in from day one. It's really easy to work with, and we have made it so that part of the device management side of this is being able to target those releases at different devices, which is really important. So let's look at it with the Thingy 91 demo that we have here. So let's look at our fleet again. I mentioned before that you can use tags when you create a device, and that's just over here. Create a tag basically with a name on it, and then you can assign it to your devices. So for instance, when I edit my device, here's the list of names or tags that I have. And we showed that network info feature that Marco doesn't have, and that's because I'm running a release candidate version of this firmware, and Marco is not running a release candidate version of the firmware. He's running a version of the firmware for his device, which is located in Croatia right here. And so on the left sidebar under firmware updates, we can see we have two options here. We have an artifacts option and a releases option. So the artifacts are the actual binaries themselves, and so you can get the hash of the binary to see what it is and compare to what it is locally. Our service detects that these are MCU boot signed binaries, which is what we're using for Zephyr. But we don't enforce the type of binary, so you can send whatever binary you want up to your devices. We get the size. Blueprints, this particular project uses all of the same hardware. It's always the Thingy 91. But in other projects where I've used an ESP32 alongside an NRF 9160, I will make a blueprint that indicates what type of hardware that is. And it can be something like right out of the Zephyr tree that you use to build the firmware, or it can be like your own made up hardware name. It just specifies, it's kind of like a tag, but you only have one blueprint and it indicates that type of hardware. And the last thing is the version number that has been compiled into that binary. So when you do a signed binary, you need to give it a version number so that the device can read that out of the binary and know what version it's running in order to report that back to the server. So once we have all of these in place, getting them to the device is a matter of releases. And so with a release, you would create a release, you would select the artifact that you're using in that release, you would give it a we already gave it a release number 1.0.11, so that's going to come here. You could give it an optional release flag like webinar release. I might have to do an underscore, I'm not sure. So I could give it a release flag like that. If I had a blueprint, I could select which device that you want it for. This is, of course, very important because you need to get the right blueprint or the right binary to the right device to make sure that it's going to run. And finally, those tags. And so if I was going to roll this out to our devices in Wisconsin where I live, I would select the tags here. And I would create the release. And we can see here's our webinar release. It's using this artifact. So you can see I have two different releases using the same artifact, which is fine. Artifacts themselves need to be unique. You can't upload the file with the same hash twice, but you can target different groups by doing different releases. And I'm not upgrading to this because I did not roll this out. So even though this exists on the server, it's not being advertised to the devices until I roll out. Since I'm really just using this as an example, I don't want to roll that out to my devices. But as an example of how this works, I can go and look at my device. On my summary page here, again, it's going to tell me I'm running version 1.0.100 and that I have the release candidate tag right here. If I go back and look at my releases, I can see here are two different releases that applies to, and both of them are rolled out. So the one that is the newest up here is the one that's on the device. I'm actually going to roll that back, and depending on my connectivity issues that I'm having today, apologies for the dog outside of the door. I should be able to come back here and go to this firmware tab, and I should see, yeah, not great. So I am having connectivity problems. So the device hasn't seen that there's a rollout available. Marco, do you want to answer this question? I'm going to service this dog. I'll be right back.
Yeah, of course. Yeah, so with our free account, you can explore Golioth in full, and you can have up to 50 devices and use our LightDB state, LightDB stream, logs, settings, remote procedure calls, and over-the-air updates to test Golioth, to evaluate it, and run your pilot, basically.
Is your device still powered on, Marco?
Yeah, it is.
Excellent. Let's see what we can do. I'm going to roll out. I'm going to create a new release for all devices based on our release candidate. Is this a bad idea? Probably not.
Yeah, I don't think it's gonna work for my device because I am on the NB-IoT network. So my
Right.
device will download it, but then it won't be able to connect to the network because I don't have LTE-M coverage at the
Okay.
location I am.
Well, let's start the download process, and we can see what that looks like. So I'm going to roll this out to all devices, and when we go back to Marco's device right here, and we see that he's on version 1.0.0. When we go to firmware, we now see that his device is running 1.0.0. The server is advertised to him that 1.0.100 is desired for his device based on what his tags are, and that he's currently downloading it. And if we go to our logs now and we put this on real-time auto refresh, we should see here are the different blocked downloads coming for that device. So we can monitor in real time because we have debug logs enabled on this device, that actually coming down. At the end, we will see the firmware state will change from downloading to updating. And what that does is the device will automatically reboot itself. It will check the signature on the binary that it received because that's to be signed with the same key as the bootloader that's running on the device. And then it will verify that it's running and it will switch over and run that. And if anything goes wrong within there, it will kind of back out of that update and start running the known working version of the firmware. So your device is going to have a slot for what it's currently running and a slot for what it's trying to upgrade to. And if there's any problems with the upgrade, it will go back to what it was previously running that was known working. All right, you can power that one down if you want, Marco, so I don't mess with your device. Let's see. Other things. Where are we on? I think we are to if you are getting up and running and you're looking for some help with the firmware side of things, I did just want to let you know we have monthly free Zephyr training with Golioth engineers. That's a hands-on training, and you can go ahead and sign up for it at golioth.io/training-signup. The other thing is if you don't want to do the live training or you don't want to wait for the live training, the training site is available for self-guided training as well, which is training.golioth.io. On this last slide, I did put some of those links that I had before, like to the docs, the forum, and the reference designs. But if you need help, don't bang your head against the table. Post on the forum. You can reach out to Devrel at Golioth.io. We want to know what you're building, so feel free to share the stuff that you have, or like if you have great ideas. We might already have something in the pipeline, but we might also just need someone to push us over and decide that that's something we should work on. So let us know what your use cases are. Stay current with all the stuff that's going on with Golioth. When you signed up for the console, you should have had the option to add yourself to our newsletter. That's got great top of mind coming out from Golioth engineers. Dan, our cloud lead, wrote one of those today. And absolutely watch blog.golioth.io because every time we figure out something cool, we publish it there. All right. Another question here about OTA. Yeah, about OTA, if there are any way to check the status of OTA for different devices based on tags, I mean, something like a graph table besides the great support of MCU boot. So we don't have a centralized dashboard for looking at OTA status. It is currently by device. However, that is all available through the REST API. So if you have a visualization platform, like we showed off Grafana before, you could visualize it through here. It is on our list of features that we think would be cool. I don't know what the priority is on that. I would think we'll see it at some point in the future, but I don't have any solid information to give you right now. I'd love to take any other questions people have before we sign off. So if you have any others, post them up. Can I test all these features that you are showing through the free account? Yes. All of these things that we had today are based on the free account. The free account is your first 50 devices. After that, there is a paid account that is like a flat rate for as many devices as you want, and then you pay based on data usage. And then once you get to really big scale, once you start to scale out, there's an enterprise account that will be tailored to your company's needs, I think, or how that worked. And all of that information is available at Golioth.io. I think there is a tag for pricing. It's right here, pricing. All right, so there's a pricing page right on the top at Golioth.io that talks about the stuff that I just mentioned, and it goes and shows you all of the things that are available for all of those accounts. And yeah, Any other questions? It's lunchtime. I'm supposed to feed the dog. That is the barking. And also she's deaf. She can't hear herself. All right. Ariana says, thank you. My pleasure. Thank you everyone for coming. Awesome webinar. Thank you. I appreciate that. We love showing this stuff off. So if you're ever like, hey, what was that? Or, do more of this, like, let us know what is interesting and what is useful. And until next time, I'm sure we'll be doing this again soon. Feel free to join us and tell all your friends about how great Golioth is. All right. Take care. Bye-bye now.
Bye.